Flux motors have gained increasing prominence in recent years, particularly following the acquisition of UK-based YASA Motors by Mercedes-Benz. In this video, we will try to answer these top 5 key questions. What is an axial flux motor? What is the difference between an axial flux motor and a radial flux motor? What differentiates the different axial flux motor manufacturers' products? If axial flux motors are so good, why have they not previously been successful? And who are the different manufacturers of axial flux motors? Axial flux motors, as the name suggests, operate using a magnetic field that is axial to the rotational axis of the motor. This is unlike a more conventional radial flux electric motor, where the magnetic field is radial to the rotating axis of the motor. Axial flux motors operate by creating a reaction force in the air gap by switching an electromagnetic field on and off around the 3 phases of the motor stator. This acts against a magnetic field in the rotor, usually from permanent magnets, but that can also be created by mechanisms such as induction. This air gap force is what creates torque. Changing the geometry of the motor from radial to axial alters both the relative surface area of the air gap and the average distance of that force from the rotating axis in a given size of motor. This means more torque can be generated in an axial flux motor of a given size when compared to a radial flux motor. In an axial flux motor, the magnetic fields are running in 3 dimensions, unlike a radial flux motor which just has a simpler 2D magnetic field. This 3D field is one of the main things that has slowed the adoption of axial flux motor technology, because commercially available 3D magnetic flux simulation tools did not exist until recently, so specialist know-how and development tools and techniques were required. In a similar principle to outrunner or external rotor radial flux electric motors, where the air gap is moved further away from the rotating axis to simply increase the amount of torque for a given air gap force. But with an axial flux machine, you also get the advantage of increasing the relative surface area by using the face of the cylinder rather than just its outside diameter. With classic radial flux motors used in EV powertrains, increasing system power density, i.e. getting more power out of lighter motors, has been delivered through the use of higher speed motors in the region of 20,000 RPM. Reduction gearboxes with larger ratios are used to increase the torque and bring the RPM down to a usable figure at the wheel. Axial flux motors create an opportunity to increase system power density, but without the need for such high reduction ratio transmissions, bringing system-level cost and performance benefits. There are 2 types of axial flux motor: dual stator single rotor and dual rotor single stator, sometimes referred to as Taurus-style machines because of the shape of the rotor assembly. Taurus-style motors are the most common in the market. YASA and Evolito, the aerospace business that span out of it, are among the most well-known manufacturers of this style of motor, along with Magnax, Saita, and Heinzmann.